Our next example then is going to be our first one for day 5, but it's example 4 in the big lesson, this 2-day lesson. So it'll be a good one to start off this day 5. You'll notice that it's a pretty big question, and we've got lots that we can do on this one. And in fact, we'll be using all the information and all the stuff that we've practiced and learned all in all 3 units, all in this one question. So it's a really great question to start the day off with. So you'll notice on the top we get x squared minus 9. On the bottom we get x cubed plus 4x squared minus x minus 4. So we need to factor this. We need it to be in factored form and allow us to investigate this much easier. The top's going to be easy to factor. It's difference of squares, so x plus 3, x minus 3. The bottom, however, is going to take a bit more work. You'll notice the bottom is a polynomial, so we're going to need to factor this polynomial using all of our factor theorems and remainder theorems. First stage of the factor theorem is to guess a number that's going to work. For no apparent reason, I'm going to guess 1. So off to the side here, I'll try f at 1. This is only on the bottom, right? So it's 1 cubed plus 4 times 1 squared minus 1 plus 4, or minus 4. So it's going to be 1 plus 4 minus 1 minus 4 is going to be 0. So therefore, x minus 1 is going to be a factor. And then I'm going to use synthetic division to divide it into this. So 1, 4, negative 1, 4, negative 4, 1, 5, 5, 4, 4, 0. And the bottom then is going to factor into x minus 1. X squared plus 5x plus 4. Luckily, that bottom trinomial can be factored further. And can get factored into x plus 4, x plus 1. So that stuff I kind of did really quickly. If you wanted to pause the video and just double check, then you could. But that's all factoring polynomials from last unit. So what we have now is an equation in factored form. And we can go off and investigate all the vertical, horizontal, and oblique asymptotes if there are any. And go off and do a sketch for this. So I'm going to go split screen here so we can, whatever we discover on the graph, we're going to be able to go off and do exactly whatever we discover on the left-hand side, we'll be able to do off on the graph right away. So our first thing we're going to investigate is vertical asymptotes. You should see that there are going to be 3 in this case. So they're going to happen at 1, negative 4, and negative 1. That's all coming from the roots of the bottom. Those are going to result in 0 and dividing by 0, which is not allowed. So I'm going to have a vertical asymptote at negative 4. Oops, sorry, I've drawn the wrong line. Negative 4. Vertical asymptote at negative 1. And a horizontal asymptote at 1. Because there's 3 vertical asymptotes, we're going to have to do 3 test points. And what I'm going to ask you to do is just pause the video for a second, and you're going to have the opportunity to investigate all of the left and right sides of this vertical asymptote on your own, and I'll show them to you quickly. So you see, if what I'm going to do is test the left and right side of each of these vertical asymptotes. So negative 4, I'm going to test the left of it is negative 4.1 and the right is negative 3.9. I'm going to do negative 4.1 with you, and I'll do everything on this one and then fast forward in the last ones. So negative 4.1, I'm going to plug it into this version, the factored version of the equation. So negative 4.1, add 3 is not going to be big enough to get me to positive, so it's going to stay negative. And if I subtract 3, it's going to be minus as well. On the bottom, I have negative 4.1. I'm going to subtract 1, so that's going to stay negative. Add 4 is not big enough, so it's going to still be negative. That was the add 4 part. And the last one is add 1. So negative 4.1, adding 1 is still going to be negative. Checking everything out here, I'm going to have a positive on the top and eventually a negative on the bottom. And all of this is going to result in a negative infinity. I'm going to now test negative 3.9. Negative 3.9 plus 3 is going to be negative, not big enough. Minus 3 is going to stay negative on the bottom. Minus 1 is going to stay negative. Plus 4 now, since it's negative 3.9, and I add 4, that's going to be a positive now. And adding 1, though, is not big enough, so it's going to be negative. So on the top, I'm going to end up with a negative times a negative, which is positive. On the bottom, I'm going to end up with a positive as well. So if I divide those, I'm going to end up with positive. So when I translate that to the left side of my graph, I'm going to have negative. On the left-hand side, it's going to go down negative infinity. And on the right-hand side, it's going to go to positive infinity. I'll quickly write out the last ones. So hopefully you got the same information as I did, having it coming from the left and right side of each of those final ones. All right, let's look at the horizontal asymptotes. So the horizontal asymptotes, we're going to investigate the degree in the top, which is n. In this case, you can see the degree in the top is 2. And the degree in the bottom is 3. And notice that it's much easier to figure out the degree from the original question instead of the factored form. However, you can get it from either one. Nonetheless, the degree on the bottom is going to be bigger. That means that n is less than m. And since we have that big number on the bottom, we know that this is going to result in a horizontal asymptote at y equals 0. So I'll quickly sketch that. Because it's at 0, I can still do the test points on this. I can do negative infinity and positive infinity. This is the only spot, because it's at y equals 0, that I can do these test points. So I put in a negative huge number. And I'm going to put it back into this one, because it's a little easier to visualize. So I put in a negative. Plus 3 isn't going to change it. Minus 3 is not going to change it. Minus 1 is not going to change it. Plus 4 is not going to change it because it's so big. And plus 1 is not going to change it. That could mean positive on the top, negative on the bottom. So it's like negative 0. Or really, the negative tells me it comes from below. So on the left-hand side, it's going to come from below. That's good because I have it coming down in the negative infinity over here, so things are working out. I can test a positive billion. Adding 3 is going to keep it positive. Minus 3 is not going to change it because it's so big. And positive's all on the bottom. And so this is going to be like a positive 0, which is going to mean it comes from above. And that's good. Oh, interesting. I would have predicted it would have come from the bottom because of this. You see this? It's coming down like there. I would have predicted that it did that. But apparently, it doesn't. It comes from the top. So this is kind of like example 3 that we did on day 4. So it looks like something weird might happen. I'm just going to double check my math, and things look okay. So I'm going to anticipate that it might do the same bump that happened in example 3. What's going to help me figure that out? Well, my x and y intercepts are going to help me figure that out as well. So I'm just going to give myself some more room. I'm going to do the y-intercept. Is when x equals 0. And the x-intercept is when y equals 0. I think it's easier to put the 0 into the original part of the equation. So it was 0 squared, so it's 0, or x squared, so it's 0 squared minus 9. And on the bottom, it's going to be 0 cubed minus 4 times 0 squared minus 0 minus 4. All those zeros are going to make my math a lot easier. And I'm going to get a y-intercept at 9 over 4. 9 over 4 for my graph is roughly 2.5. Or sorry, 2.25, I think, right? Yeah. So I'm going to go to 2.25, which is about here. Nine over 4 is a more accurate number, but of course when I go to the graph I don't have 9 over 4, so I've changed to 2.25. I'm only ever going to have one y-intercept, otherwise it's not a function, so I'm good. Now the x-intercept. The x-intercept I'm really interested in because I'm curious I'm going to have that bump over here. So I'm anticipating I'm going to have an x-intercept someplace around here, maybe around 3 or 4 or so, and might be able to explain why I have that graph coming from above. So the x-intercepts when we have the top. Now I think it's going to be easier to use the factored version of this. And that bottom, I'm not even going to bother writing those 3 factors from the bottom because it's going to get multiplied by 0, so it's going to disappear anyways. So I really only need to look at the top. That's why it's nice to have it in factored form in the top, because now I can clearly see my answers that are going to get me a 0. I'm going to have an x-intercept at -3 and a second one at 3. So -3 is over here. Now be careful when you count. This is -1, this is -2, -3. So I'm going to have an x-intercept right here. And then there is going to be that other one over to the right, which is good news because I kind of anticipated it happening. So this is at x equals 1, 2, 3. There it is. And so I do indeed have that bump happening. So now I've got all my clues, and I can take all this information and finish my sketch. On the left-hand side here, I have it coming from above and going down to -infinity, so the graph is going to do something like this. This middle thing is going to cross the horizontal asymptote, which is okay. Locally, it's allowed to do that. At the end behaviors, it doesn't. But here, it's going to come up from here and cross at this point, and then do our little snake down to this. Probably shouldn't have that as close to the asymptote, but I think we get the idea. In the middle section, I have it going off like this, and touching, so I have like a little parabolic shape. It's not a perfect parabola, but it does have parabolic tendencies. And then here is that spot at the end. It's going to have that bump. So it's going to go down here, but then eventually go across and come up from the top. So it's going to go up like this, have a bump, and then come back. Calculus later on will tell us how high that bump is. It's probably not as high as I've graphed, but I'm going to exaggerate so I can see it. And what I have now is a pretty good sketch of this pretty complicated function. And it does involve everything that we've done this semester.